Hello and welcome to this presentation of my project called RToy. So RToy is something I'd like to call a virtual home computer. And what I mean by that is that it's well, practically it's a C++ application with an embedded Ruby interpreter, a set of classes that gives you access to audio and graphics, input and timers and such, and then also a set of Ruby files that takes advantage of this. So it's nothing special in that sense. So what I mean with home computer is that I try to design it in such a way that it mimics certain aspects of the home computers of the 80s and early 90s, the kind of computers that me and other people of my generation grew up with and learned to program on. And specifically, I want a system that's more understandable and maybe consistent than what you would get when you program on a normal modern computer. I mean, you can't really understand how a modern computer is put together with hardware and software. I mean, I understand most parts of it, but nothing in detail, and that's only because I've been around for a long time. Whereas a home computer like a Commodore 64, you could understand it. You could disassemble the ROM, and you could read through the ROM and basically understand most of the operating systems, and you could target any hardware directly without going through the operating system. And it was not only possible, it was also kind of the normal way of doing it. And in doing it this way, it was easy to learn, experiment, and understand. And that's what I'm trying to accomplish here, kind of. So I'll take a simple example. This is RToy running here. So one of the first things maybe that you would do when trying out a new language or a new environment is to try to print something on the screen. Like that. And maybe you're satisfied there, it prints, but maybe you also wonder, like, how does printing text work? I mean, where does it appear? So there's a cursor, but can you put text in other places in the cursor? And what is text? What are characters really? And then hopefully you will come to understand that yes, this is just a grid of tiles of graphical objects, and you can put text anywhere on the screen, and you can redefine the characters to other graphics because they are just pixels. I'll show you more of that later. And so that's kind of the things I'm going to show you a bit here. So right now I'm just demonstrating some things about the console, which is one of 4 layers here. This display here is it consists of the background, the text console, a canvas for drawing pixel graphics, and on top of that there's a sprite layer for putting sprites, and you can use that all together to program games and such. So let's do what it says here. Let's say help, and there's a tutorial. And the tutorial is a Ruby file, just a simple Ruby file with snippets of code that you can comment and uncomment to experiment with. Now, since I just played with this, I think I actually have some code down here that I should comment out before we do this. So we already seen print. Let's go down here and we uncomment this line here. So now this is the only line in the file that is does not have a comment character in front of it. And if we press F5, this code will run. Then we press F5 to get back to the editor again. So this is one of those classical effects that was maybe one of the first things you did on your Commodore 64 there's an entire book about it. You can create a simple maze by just randomizing between two different diagonal characters. Okay, let's move on here to this is, we hook up an event handler by calling onDrag, which lets us specify some code that will be called anytime you drag the mouse to a position. And you might be able to guess what will happen if I run this. A very primitive paint program. And we can do a little bit better by actually both hooking up the onClick handler and the onDrag handler. So here, when you click the mouse, we will save the coordinate. And when you drag the mouse, we'll draw a line from the saved coordinate to the new coordinate and replace the saved coordinate. And that gives you a continuous line instead, which is more what you would see in a normal paint program. Okay, so back to this ball function that I just commented out, and I now have to comment back in again. So yeah, this editor is very primitive. It's around 300 lines of Ruby code. Of course, at some point I want a better editor, but for now this will have to do. So let's look at this function. Def introduces a function, by the way, and this function will load an image from disk. It will create a sprite and move it to a random position on the screen. It will create a random velocity, and then it will call this tween function, which I will talk more about in a bit. For now, just know that these 4 lines of code will be executed repeatedly for 10 seconds. The position of the ball will be increased by velocity, and if we hit the edges of the screen, we will reverse the x or y factor of the velocity, and after 10 seconds we will remove the ball. And okay, nothing happened because I don't call the function. And let's call it like it says. Let's call it 100 times. We get 100 bouncing balls. And I guess now in the video this will look kind of jerky because of the frame rate, but in reality this is pretty smooth. You can have a lot of these. Okay, I think that was it. Yeah. Okay, let's maybe move on to something a bit more advanced. I mentioned tweening, so let's take a look at an example that uses tweening. So here again, we load an image, and now we call the split function, which splits the image into 20 by 2, so 40 new images. And we then call add sprite for each image, and that will be returned here in sprites. So sprites becomes an array of images. And then for each sprite, we do this. First we scale the position of the sprite to the new scale that we had before, so we will, that's in preparation for the animation that's coming here. So here we call the tween function I talked about earlier. So tweening, if you don't know, is a way of animating properties of an object over time. That's all it is, more or less. I learned about it from programming ActionScript and Flash, and there's also I think it's pretty popular in JavaScript and web programming as well. It's a very easy way to move around UI objects and text and things. So here we say we will tween this sprite over 3 seconds. We will move it from a random position on the screen and from a random rotation and to this scale. So you can call both from and to say which direction the tween will go. And we do this for all the sprites. So it will end up at the original position, but it will start from this position here. And if you run this code, we get this nice little effect. There's also, like I said, you can also, besides graphics, you can of course do audio. I have this little piece of code. I'm not gonna explain this because this code is a bit more complex. Oh, I can just mention that yes, this code sets up the white keys and the black keys of a piano by drawing rectangles and then creating kind of a lookup table for those rectangles to the corresponding notes. And then we again hook up the click and drag handlers so that we can play these notes when we click the corresponding keys. And let's hope I have sound. So that's audio, and that was Sprite's Tweening audio. Let's look at some games. Let's start with Snake. Snake was one of the first games I made for Artoy. It's a very simple game. It's particularly easy to make on a home computer with a tile-based graphics, because you can, or text, if you have a text screen, you can just, this is 110 lines of code. Let's look at it first. Not surprising. So what I want to show you is like a lot of like early games you did was just based on text because it was so easy. You didn't have to draw any graphics, you could just play with what you had. But we're gonna quickly move on to another game here, which is Sokoban. So this game also uses the console and draws tiles, just like Snake did, except Snake used existing characters in the font, but Sokoban uses graphics. So we can take a look at this setup tiles function here. It loads a tile sheet. This is a set of tiles, images. They are all 64 by 64 pixels laid out. And then again we use the split function of image to create one image per tile. And we take all of these tiles and we define new tiles in the console. So now whenever we try to use a character, type a character to the console that is 256 and higher, we will instead get some graphics from this tile sheet. I'm not going to show you, I'm not going to explain the rest of the code. This is a little bit longer than Snake. It's about 170 lines of code. It does things like it loads levels, it renders the level, it checks if all the boxes are in the correct position, etc. It looks like this. Yeah, we have one box done. And then we do this, and now we are in an unwinnable state. Okay, I'm gonna stop there before it becomes too much. Just say that this is an open source project. It's on GitHub. It's written in C++. It's fairly easy to port. It works on the web. You can go to apone.org/toy to play with it there. And I hope that this will inspire at least one or two people to help out eventually. Okay, thank you.